Okay, it's 11:05 and we have over 40 people in the call, which is wonderful. So I think that we can begin now. So, good morning, everyone. Once again, thank you for joining us today. And welcome to the webinar, Rebuilding the Future, Circular Innovation in a 3R Modular House. My name is Vladimir Nedeljkovic, and I'm representing the Serbia Green Building Council, a proud partner in the Circ-Boost project. I'll be your moderator for this session, and I am honestly truly pleased to see such strong interest in this topic from across the field and from across Europe. As mentioned, we have over 40 people in the call, which is wonderful. Now, at today's webinar, we'll be diving into the story of the 3R Modular House, a practical example of how circularity can be integrated into real-life construction practices, which is happening right here in Belgrade, Serbia, although I'm aware that here may not be Belgrade for you. But throughout the webinar, you will hear from a number of experts, academics, researchers, and industry professionals who work closely on the 3R Modular House. They will walk you through the materials used, the construction methods applied, and the lessons learned that we believe can inspire similar initiatives across the region and beyond. Now, I won't take up too much of your time today, as we truly do have an excellent group of speakers who are true experts in their respective fields, and I would like to take this opportunity to introduce both them and today's agenda. First, we'll hear from Ivan Ignatovic from the Faculty of Civil Engineering, who will present the Circ-Boost pilots and focus on Pilot 3 in more detail. Then we'll hear from Jelena Carevic, Nenad Fritz, and Marko Marinkovic, also from the Faculty of Civil Engineering, who will offer a deeper perspective on the research aspects of the pilot. Then we will have room for questions before turning to the industry side, when we will hear from Mihailo Ristic of Pentageco and Nikola Radovanovic from Beam Europe. Following this, we'll have another round of questions, and then we will wrap up. Now, we encourage you to stay engaged throughout the session, and you can use the Q&A function in the window to ask any questions you have throughout the call at any time you have them. When we get to the Q&A section, we will go through these questions and our speakers will be able to address them. If you'd like, you can also wait for the Q&A section and ask them, but please do feel free to ask any questions you have at any point. And before I hand over to our first speaker, I would just very briefly like to introduce Circ-Boost as a project for those of you who are new or unfamiliar. So this is a Horizon Europe funded initiative that brings together 27 partners from across Europe with one shared goal, which is to accelerate the transition to a circular economy in the construction sector. Through innovative business models, pilot demonstrations, and digital tools, Circ-Boost supports more efficient use of materials, promotes reuse and recycling, and helps reduce the environmental footprint of buildings across their life cycle. And on this slide, you can see that our 27 partners come from both all corners of the construction sector and also all corners of Europe. Circ-Boost is also a member of the Circular Cities and Regions initiative, where it collaborates with its sister projects on achieving our shared goals on circularity. One of the key features of Circ-Boost is our 5 pilots, which is each located in a different country, and you will hear more about this very soon from our speakers. And as mentioned today, we will focus on Pilot 3, which is the 3R Modular House. But before I hand over to our first speaker, I would just like to point out that today's webinar is just the first one in a series of webinars which will be taking place over the next 2 years. We also have a multitude of local and online events with each specific pilot in the 5 countries. Circ-Boost is also often present at many conferences and international events, and we also host joint events with our sister projects. And these are all opportunities for you to get involved, find out what's happening, and keep up with the project. And to know about these events, the best way to stay in the loop is to follow the project online. So with that, I will now hand over to our first speaker, Ivan. Ivan, one moment, sorry. Okay, Ivan, the floor is yours.
Yeah, hello, everyone. I don't see the slide, my first slide. Just a moment. I see the last slide upcoming. Vladimir, can you hear me? You're muted. Hello?
Yes, sorry, I can hear you. I'm not
Okay.
sure why. We can see the slides. So you are now on the work package 3 position in the project. And you are now on the...
Yeah, but I saw your slides, but it stay at the moment. It stay at the slide upcoming. It's slide number 5.
Oh, it might be frozen for you, but no, you are moving the slides. Yeah, I think it's an internet issue.
Uh-huh.
And of course, it works perfectly every time
Okay,
we
maybe
test it.
to leave and enter again.
So right now you are on your headline slide.
Yeah, but I don't see it, so I can't control. I don't see.
Okay, one moment. I will stop sharing and then I will reshare. Just one moment.
Okay.
Apologies, of course, that something has to go wrong. So, right. So hopefully now you see the correct
No,
slide, yes?
no, I don't see anything now. Now it's completely black.
Still? All right. Well, while Ivan rejoins, I will take this opportunity to introduce him just so that we don't lose track of time. So Ivan, as you can see, is an associate professor at the Faculty of Civil Engineering, and he is also the leader of Work Package 3, which governs not only Pilot 3, which is the project in Belgrade, but also is responsible for all of the pilots across the Circ-Boost project. This includes the pilot in Barcelona, the pilot in Prague, the pilot in Paris, and in Norway in Vesterålen. Um, and hopefully we will have him back very, very shortly so that he can take over. Apologies for the delay. Unfortunately, the general test was not the one we're seeing today because yesterday everything went very smoothly. Right. And then maybe if Ivan does not return shortly, we can circle back to him.
Let's wait for him 1 minute more. I think it's
Yeah.
better than to lose the. It happens. Most probably it's an internet connection issue.
Likely.
So can you hear me now?
Yes. And can you see the screen?
Yeah, I see the screen, my first slide.
Yes.
Just
And you have control.
Just to check whether I can change.
Yeah.
Yeah. Is it okay?
Yes.
So you see the
changed.
second one?
Yep. There we go.
Okay. It's moving back and forward.
Okay, there we go.
Okay, so let's start. Since it works. Okay, hello everyone. Again, I'm Ivan Ignatovic, Associate Professor of Concrete Structures at Faculty of Civil Engineering, Belgrade, Serbia. And in Circ-Boost project, I have a role of Work Package 3 leader. And I will give an overview of plans and activities done so far within this package, means within all pilot projects, including pilot 3, which will be present in details in the forthcoming presentation. Okay. Yeah, so this presentation will be consisted of 2 parts. A brief introduction into pilot position in the whole project and overall objectives will serve as an introduction. And in the second part, plans and commitments we made in the project proposal regarding the pilots, specific goals we aim to achieve, and overview of activities done in the first 18 months of project life. So as we can see, so as we can see here, working package 3 with its pilots is in the core of Circ-Boost project together with the working package 4, and it is very well connected to other working packages like train, evaluate, and marketize, which should lead to achievement of overall objective, and that is to enable and demonstrate an increase in the large-scale uptake of integrated circular solutions in European construction value chains. However, today, actually, we demonstrate connection with other working packages, with the working package 2, Connect, and working package 8, Promote. So one of the key values of our project is diversity of pilots. The spatial, social, and economic conditions for implementation vary, and as well as the content of the pilot. Yep, that is the slide. So the planned activities of the pilots reflect specific needs and challenges for each region. However, all pilots share a common goal. And the pilots will be implemented in 5 countries, as you can see here on this slide. So Spain, France, Serbia, Norway, and Czech Republic. So each pilot has its specific task and results that are measurable and will be used to monitor the success of both pilots and project as a whole. Apart from the overall objective that I have already mentioned, specific objectives for each pilot have been defined. And for example, for the first one, Spanish pilot, one of the key challenges will be development and integration of BIM-based digital twin with LCA and the multi-criteria decision-making method, as well as use of low-cost wireless sensors and NFC tags for recovered elements and recycled material traceability. And it is very interesting pilot. Physically, the demonstration site will be La Mercedes Eco District, and it has been designed in 1951 as an aircraft engine factory. And circular approach is carrying out through all stages: demonstration, demolition, design, and construction. And there are plenty of climate-neutral solutions that have been developing and demonstrating within this pilot. So you see the slide with the old district. Now it is a demolition site, and here I hope on the next one you will see how it is. It will be by the end of the project, not of this project. This pilot is a part of larger project which take care about this La Mercedes Eco District. Regarding the major achievements so far, Pilot 1 was focused on nature-based solutions in soil decontamination. And during these activities, point cloud scanning of the excavated materials were carried out. Generated point clouds were successfully converted to BIM object that could be manipulated, allowing for attribute assignments and property determination, such as volume, as you can see on these small pictures here. And the third line of action within Pilot 1 is development and deployment of radio frequency identification tags for multiple life cycle traceability of construction materials. And on the right side of this slide, you see design drawings for some elements which can be assembly and disassembly, and it has been done in cooperation with the industrial partners. So the model of this house you see here. Regarding the second pilot, French pilot, circularity of proposed solution is demonstrating by development of digital but also physical platform that will centralize the flow of materials and waste in one of Paris region, Plaine Commune. The platform will facilitate the matching between supply and demand for materials and waste, allowing for a better identification of construction waste deposits and regional needs. Furthermore, the aim of this pilot is to explore innovative construction processes and that enhance the value of materials obtained for deconstruction. And regarding the results so far, Pilot 2 has been engaged in development of digital platform for recycled material management, but also they done the state of art in the field of existing physical platforms of material preparation and environmental analysis and ALCA. A few words more about Serbian pilot. This is the third one, which is in the focus of this webinar. Balkan region construction industry has been growing in the last decade, but business is being done in traditional way with insufficient consideration of the environment. The focus of this pilot project is to demonstrate possible application of different structural elements and solutions developed by our faculty and industrial partners, of course, but upscaling them horizontally from laboratory to the real environment and vertically from individual parts that we have already tested in laboratory to the functional system modular house, which we will build. At least 5 innovative and integrated solutions will demonstrate principles of reuse, reduce, and recycling for fast building and disassembly of this small house, which you can see the sketch of that house you see on the right side. This house can serve for urgent accommodation of people after natural disasters like floods and earthquakes, for accommodation of refugees or social vulnerable groups, but also like exhibition pavilions or working hubs. The demonstration house will be built from recycled aggregate concrete, which is a concrete made from aggregate obtained from recycling of concrete debris. Will be made from fly ash concrete. So fly ash in high volumes will replace the cement, which is responsible for a large amount of CO2 in environment. Eco-efficient composite steel concrete floor, modularity-based moment-resisting frame system made from reusable steels, reused masonry, and recycled rubber. The position of this pilot site will be actually the backyard of our faculty. Although only structural elements have been foreseen as a part of this project, we are working on to include also non-structural elements and solutions in this 3R house, which can be considered as sustainable and circular, such as energy efficient facade, glass, and modular green roof. So from the outside, the structure will be covered by materials that will provide sustainability, and inside the house, all structure elements, joints, and connections will be visible and available for presentation to representatives of startups, spin-offs, SMEs, and other companies that would like to further develop these solutions. And by this, actually, we will achieve the main goal of the project, the uptake of circular solution by the industry. So during this first 18 months of the project life, Pilot 3 advanced with the design process of house, supply of recycled materials and other materials that will be reused. And this supply chain have been challenging issue, and we will hear and discuss about that. And finally, numerical tests as preparation for prototype testing were conducted, as you can see, I think, now on the right side. The fourth pilot will be in Norway. So specific objective of this pilot will be use of waste materials from 2 demolished buildings and use containers from the fishing industry to construct a new Gaia Westerland Museum for high-tech art exhibition. And this pilot is also part of the larger project of this whole museum. So one small part of the whole museum will be built from these recycled and reused materials. So at the moment, Pilot 3 dealt with the preliminary materials testing taken from demolition site, and you see in these tables some technical data, some results from this technical analysis. Finally, fifth Czech pilot will be focused on the use of 100% recycled aggregate concrete for structural and non-structural purposes, from base concrete slabs and reinforced concrete walls to facade panels, wall tiles with exposed surface, urban furniture, and demonstration site will be south part of Prague, so-called Modransky Cukrovar. And this pilot is the most advanced, with a lot of implementation of recycled concrete in real project, and you can see some part of this, so non-structural and structural application of these materials at the construction site. So very important part of our proposal, but also technical review that we have had is analysis of fulfillment of expected outcomes. And here we see to which of expected outcomes our pilot projects have given contributions so far. As we have just finished the first third, I would say, of the project life, outcomes are coming mainly from the design stages. Outcomes like optimized design of recycled concrete mixes, or design of precast elements made of this concrete type, and development of nature-based solution, solid treatment. And we also organized 2 trainings based on outcomes and baselines from 2 pilots, which were very nice. And some outcomes can be considered as a part of construction stage, even now after 1.5 years, like in most advanced pilot 5, where as in outcomes, we already have a plenty of structural and non-structural application of recycled aggregate concrete. So briefly, this is working package 3 and all pilots. And now we will hear more about pilot 3, which is positioned in Belgrade. Thank you very much.
Thank you, Ivan. Yes. So at this point, we will move on to Jelena. Please let me know if you can see the slide. And
Yes.
okay, perfect. There we go.
Great. Okay, hello everyone from my side also. My name is Jelena Carovic. I'm an assistant professor at the Faculty of Civil Engineering at the Department for Materials and Structures. And over the next few minutes, I will present circular concrete elements that are featured in this 3R modular house. And this will be done mostly from the point of the use of recycled aggregate concrete. So this house will be the first modular house constructed in Serbia using recycled aggregate concrete. In fact, it will mark the first actual application of recycled aggregate in some structural elements, in structural application, because until now, only limited use of recycled aggregate in Serbia has been mostly confined to the road sub-bases, well, actually mostly temporary road sub-bases. But having in mind that the construction industry is experiencing growth, a large amount of concrete waste are being produced in Serbia, or well, in Europe and in world, but particularly in Serbia. And it is estimated that over 0.5 tons per capita of construction and demolition waste is being annually deposited on landfills in Serbia. And unfortunately, most of this waste ends upon illegal waste dumps, leaving the waste trapped in this polluting cycle. So this is why we aim to showcase the potential of recycled aggregate concrete in structural application, focusing on precast concrete walls and concrete columns connected to foundation with demountable connections. Precast concrete columns and strip foundations will be made with 100%, of course, recycled aggregate concrete with an optimized mix design incorporating limestone powder. The demountable connections between columns and foundations will utilize wall shoes embedded in the columns and bolted connectors with mechanical couplers embedded in the foundation. These mechanical couplers not only secure the connection, but also create a flat surface at the connector location, facilitating easier disassembly compared to other demountable solutions. This type of shear connector consists of mechanical coupler embedded in the foundation and anchored with the reinforcement. The column is then connected to the foundation with this demountable bolt inserted in this coupler. This is maybe just a bit too slow. Just a second. Okay, a similar design philosophy will be applied to the connection of precast concrete wall and precast foundations. In this case, wall shoes will be embedded in the concrete walls and bolted connectors with mechanical couplers in the foundation. And both column to foundation and wall to foundation connectors are commercially available products intended for the use in traditional natural aggregate concrete under static loading. And in this project, in this pilot house, this connector system will be evaluated under static and dynamic loading and for these elements made from recycled concrete aggregate. The detailed design of the modular house was done to ensure safety, serviceability, durability, and easy assembly and disassembly. So first, the mountability of all elements will be evaluated, firstly on individual elements and afterwards in the complete house throughout assembly and disassembly trials. Serviceability testing including deformation, deflection, and vibration measurements, will be conducted in situ after the pilot house is constructed, assembled in the faculty's backyard. And ultimate load testing will be performed in the laboratory to evaluate the behavior and resistance of reinforced concrete column and its connection to the foundation under static and dynamic loading. Okay, so so far the challenges in our project implementation that we encountered are mostly related to underdeveloped market for recycled aggregate in Serbia. Currently, there is only one waste treatment plant in Vinča in Belgrade that provides recycled concrete, crushed concrete that can be purchased. But this concrete needs to be further crushed or sieved for sizes necessary for concrete application. And this material is currently not being tested or characterized at the waste treatment plant. So this is something that the user needs to do. And of course, there is no consistent flow or a stockpile of this recycled aggregate in Vinča. So this leads to a significant quality variations and limited availability. So, for example, at the beginning of our project, we obtained 2 samples of recycled concrete aggregate. The first sample had a water absorption over 6%, and the second something around 3.6%. This difference is significant, and it influences or limits the application of, for example, this 6% absorption rate aggregate in structural application. The second major challenge we encountered was the challenge of the transition from the laboratory to the construction site, to the factory industrial application. Even though Pentageco, which is a partner in this project, has a modern precast concrete factory, like all of them, there is no a precise method and a way to measure the humidity of aggregate and to determine the exact content of water in the concrete mixture, for the concrete mixture. And this is not a crucial problem for natural aggregate concrete. It needs some trials at the beginning, but it's something that is not so not crucial for the production, but it is a significant parameter for the production of recycled aggregate concrete due to high absorption rate of recycled aggregate. So to address this issue, together with designers in Penta, we are developing procedures for the measurement of humidity content, measuring water content, mixing techniques, for guidelines for easy industrial application. In collaboration with our stakeholders, we identified key barriers to the industrial application of recycled concrete aggregate in Serbia. And the Circ-Boost project will address and help overcome some of those challenges. So first, the demolition waste management system in Serbia is underdeveloped, as I mentioned, with a lack of selective demolition and sorting on site, on the construction site where the buildings are being demolished, and a lack of processing facilities. So within this project, we want to make a direct connection between that one waste treatment plant in Vinča to the industry and to disseminate information about the supply of recycled aggregate, how it can be characterized, and what are the possibilities for its use. Aside from that, many engineers and construction companies are unfamiliar with the mechanical properties and benefits of recycled aggregate concrete. Some of them even have a perception that it has inferior properties compared to traditional concrete. So within the Circ-Boost project, we are planning to organize workshops and seminars for the industry to showcase recycled aggregate concrete properties, to provide with the developed, optimized recycled aggregate concrete mixtures, and guidelines for industrial production of this concrete. There are no clear quality classification for recycled aggregate, and this leads to uncertainty among the designers and contractors about the performance of this aggregate in structural concrete. So Circ-Boost project aims to develop guidelines for precast concrete columns and walls implementation and a real-life demonstration with this pilot house to help gain trust in this material and increase the increase recycled aggregate concrete market uptake. And last, but maybe the first in the hierarchy, there are no strong government mandates or incentives to promote circular construction, and also there are weak enforcement of demolition waste and recycling laws. So all Circ-Boost project results will be disseminated to public regulatory bodies together with Serbian Green Building Council to help accelerate Serbia's construction industry green transition. Thank you so much. I'm looking forward to hearing your thoughts and questions about these aspects.
Thank you, Jelena. We will now move on to our next speaker, Nenad. Just one moment. Nenad, you should have control, and the floor is yours.
Thank you. Hello, everyone. This is Nenad speaking. I'm assistant professor on the Faculty of Civil Engineering, University of Belgrade, dealing with steel structures all my professional life. Today, I have a pleasure to introduce all of you with innovative, demountable steel solutions in reusable 3R modular house. So, on this slide, you can see beam to column joint of the reused steel moment resisting frame in the front side, the 3R modular house. You can see it in the top right corner of this slide. Here, this is the frame. So this is fully demountable joint with no welded connections, which is very important. I would like to draw your attention at the linking elements between the beam and the column, because those elements are designed to allow length adjustment for used beams. It's very important also. All components are made from hot rolled steel sections, and experimental tests of the prototype joint have been completed in the laboratory environment last month, so March 2025. And so on, finite element simulations are ongoing for further evaluation of the joint behavior. The next one, well, the conceptual structural design of our 3R pilot house brings the demountable and reusable solutions of steel column now to concrete joints. This joint is also a part of the moment resisting frame, the same frame in the front side of our 3R modular house. So we propose two solutions. First one, the fixed moment resisting base, and second one, pin base. This is also fully demountable and reusable steel to concrete joint without welded connections again, and also all components are made from hot rolled steel sections. Development and assessment of the presented steel column concrete joint will be performed through experimental also tests and finite element analysis. Preliminary finite element analysis are performed, and experimental testing in the laboratory environment is being prepared. We expect it to be realized in June 2025, let's say for three months. And now a few sentences on next two slides about as a brief illustration of steel structural reuse potential in Serbia. Well, only in Belgrade area, there are more than a dozen old industry complexes, which will be unfortunately demolished due to construction of course, new residential and commercial buildings. And all of these complexes were built after World War II, so their structural elements are more than 70 years old. And as an example, we can use old EMT industry, where we have more than 25 old objects, and many of them with the bearing steel structures. The thing is very interesting is that investors are very aware of the reuse potential of these old structures, and they are very, very resolved to keep that structure after dismantling and to try to sell it as structure and not as waste. I'm quite sure that everyone can guess the difference in the price in that case. We can today proudly say that in Serbia we have at least one successful reuse of steel structures in Serbia. Well, international company Baumit decided to transfer its factory from Celje, Slovenia, to Aranđelovac, Serbia, and to reuse as much steel structure as it is possible. Important thing is that this project finished successfully in 2024. And at the end of the project, about 60% of original steel structures was reused, and about 40% was replaced due to new technological equipment. At the end, something about procurement of reused steel profiles. Well, Faculty of Civil Engineering initiated contacts with several companies involved at that moment in ongoing steel structure dismantling projects for procurement purposes. Site visits were conducted to identify suitable steel components for the fabrication of new structural components for their use. And at the end, thanks to the understanding of investors and contractors, we managed to collect the necessary material for our research. Thank you for your attention.
Thank you, Nenad. Our next speaker is Marko.
Hi everyone, I hope you can hear me well. I'm Marko Marinković, also assistant professor at the University of Belgrade, Faculty of Civil Engineering, and I will talk today about the reuse of bricks and together with the recycled rubber connection to make the walls earthquake resistant. We'll start from this topic of earthquake resistant. What does it mean? So I will show you just a couple of examples from the previous earthquakes. There are a lot of examples like this, but we don't have enough time. But for example, from Italy, you can see more or less some kind of pattern of these infill walls, masonry walls, so walls made out of the bricks, damaged in every earthquake. This was also the case in Turkey, the earthquake that we know that happened 2 years ago. These were the sceneries that we documented on the site. So if the reinforced concrete structures survived, the infill or the brick walls didn't survive, and that's what we want to solve. So I collected here a couple of photos to see the pattern, or to show you the pattern that all the walls, brick walls, were damaged and collapsed in the lower stories due to the interaction of the earthquake load in both directions. And therefore, we saw a lot of landfills full of waste from the earthquake. So at the top, there were photos of the landfills taken next to the highways. And at the bottom, photo of the damaged cars that were standing next to the buildings on which the walls were falling down. So what we propose is the solution made out of the recycled rubber connection. And this connection is used to connect the wall and the surrounding frame, reinforced concrete frame, on all 4 sides. So in this way, this connection that we call the nodis is providing the in-plane decoupling and at the same time out-of-plane restraint, so that when the earthquake happens, you can see when it moves back and forward, then one side of the rubber gets compressed and the other side there is always connection holding the wall not to fall in out-of-plane direction. Besides protecting the walls and, let's say, not allowing them to get damaged and then saving costs there, we are also using recycled rubber. So the old tires from the landfills also to make this rubber connection. This is how it looks like in the construction and in the lab, the walls that we tested. And this connection is additionally allowing us to use the old bricks. So from the old buildings that are getting, let's say, damaged or demolished, we can take the old bricks, because now all the movement from the earthquake or of the structure is getting to the rubber, and the rubber is getting compressed with its elastic characteristics and is not transferred to the wall, which is usual in the case when you don't have this soft connection, when you have the rigid connection with the mortar. Therefore, we can use these old bricks no matter how strong they are, and that allows us really to make this effect of reuse. For example, in this pilot, we'll use there is an old factory of meat industry built like 70 years ago that is currently under demolition. And from this factory, they will demolish it, we'll take the bricks and reuse it in our pilot house. So this is the detail of the wall that will be placed inside this precast concrete elements and the steel beam that Jelena and Nana were talking about, and we'll connect it with the rubber connection that will allow us to use also the precast masonry wall or brick wall in order to assemble and disassemble and assemble again the wall as, let's say, prefabricated element, all thanks to this recycled rubber connection. And this is how it looks like in some renders. So between the steel and the wall at the top, there will be rubber connection, and also on the sides, these three strips of the rubber will be connected with the regular mortar to the concrete and to the wall. And here just a short calculation example to show the benefits of this connection. We did a full design in the 6-story building in a case when there is a rigid connection, and in that case, all the codes and also engineering judgment says, of course, there is interaction force, this shear force that has to be taken into account. This shear force is resulting in higher amounts of concrete and reinforcement that has to be taken into account in comparison to the case when you use this recycled rubber connection. In that case, you just need to define enough thickness. Is it 1, 2, or 2.5 centimeter of the rubber? And there is no this shear force, therefore the shear demand on the columns and the reinforcement on the columns is lower, therefore there is less use of reinforcement and concrete. Thus, we save the money or investment cost during the building or rebuilding structure. And at the same time, because we are using, let's say, recycled rubber connection, but we also use less concrete and reinforcement, we are also saving CO2. So there are a lot of benefits. And then the one that I started the presentation with is that we have less waste in the case of earthquake because the brick walls will not get damaged. Thank you very much.
Thank you, Marco. Now, given that we are just on a slight delay and that no one has written questions in yet, I propose that we move on to our next speaker and then have one unified Q&A at the end, just so that we can make up some time. So with that in mind, I would like to hand over to Mikhailo.
Hi, everybody. My name is Mihailo Ristic, and I'm working as a head of commercial and residential sector in Pentegeco construction company from Belgrade. At the beginning of Vladimire, ne mogu da ga okrenem.
Samo malo levo, pošto je na to.
Aha. Evo ga. Okay. At the beginning of this presentation, I would like to say something about KMZ Group, which part is Pentegeco Construction. Pentegeco is a company which do projects as a general contractor, and we do all kinds of projects. In our group, we have a few factories. Another is MG Precast from India. It is factory for prefabricated, pre-stressed concrete structure. Another factory is in Italy. Its name is SPI. It is factory of prefabricated railway tunnels. Our third factory is in Serbia, and this is a factory for precast concrete pillars for the installation of anti-hail netting. Our companies are not from construction industry, so I will just mention that we have Burnout. This is distributor for Ducati motors and producing of Blueberry. So let's see a few more words about Pentegeco. Pentegeco is a company which do all kinds of projects. So here we can see a time frame of our key projects. So there is one bridge. We finished a lot of logistic centers, retail parks, all kind of commercials and residential buildings. So now I would like to say something about Serbian construction practice. And I will mention just a few projects which part I was. So I will mention other shopping mall from Belgrade, where which project is done under Gold LEED certificate. There is another project from same client, GTC 41, which is finished, which is done under LEED certificate too. It is important to say that same for this project is that they have tenants, and very often, especially for big tenants, there is a request that tenants will come to rent some space from your commercial object if this is done under any green certificate. So in this case, it was LEED certificate. Another project which is a little different, this is Capital Park in Rakovica. On this place, few years ago, there was an old factory, and in next demolition of this concrete structure, we produce concrete recycled aggregate, which we didn't use for future concrete. We use it for backfilling of all this area. So with this recycled concrete aggregate, we backfilled 60,000 square meter all this area. Approximately, we backfilled 1.5 meter. Now I would like to say something about real industry challenges which we have on Serbian market, and I honestly believe in other European countries. On the first place, there is a problem when we are talking about low quality control and availability of recycled concrete aggregate. Another one is that we don't have standardized recycled concrete aggregate on Serbian market. And this is honestly, this is a problem if some company would like to apply this material and use for construction. Maybe on the first place is cost benefit. This cost benefit still is not clear, because cost of processing and sorting demolition waste material is still very high. So natural aggregate is cheaper than recycled. So this is very, very big problem when we are talking about green buildings, because every company on the first place want to see cost benefits. On the third place is investors' motivation. Maybe the best example I already mentioned on the shopping mall and GTC projects. Investors see motivation when we are talking about tenants, because if they do their projects according to some green standard, they can to rise their cost of rent for square meter. So next problem is that we don't have strict regulation mandating recycled concrete aggregate in use. And at the end, it is very important to say that industry still prefer more prefer natural aggregate because of ability and the cost. And this is a few problems which we have and which we have to solve in future if we want to more use recycled aggregate and to change something in our future environment. Thank you very much.
Thank you, Mihailo. And our final speaker, who will also provide an industry perspective, is Nikola Radovanovic. Nikola, the floor is yours.
Hello. Thank you very much, Vladimir. Hello, everybody. I hope you guys enjoyed the previous presentation as much as I did, and hopefully we'll finish in the same way. My name is Nikola Radovanovic, and I'm working in company BIM Europe, situated in Kraljevo, Serbia. We are a company that changed the name 2 years ago, since we are acquired from the US-based company BIM Global. So now we are working under the name BIM Europe. Formerly we were working under the name Amiga, which is kind of the brand in the region for the products in the area of public poles lighting for the streets and roads, then for the floodlights and flank poles, like what you see at the stadiums. And apart from that, we work in we're producing different steel constructions for different kind of applications. With the entrance of new owner, we added the scope of our business in the let's say more sustainable and green part of the business. We are now patent holder of these advanced solar chargers for EV vehicles. Those are completely off-grid solutions for charging of the vehicles or e-bikes. It's an innovative product. First examples of such products are installed on the Belgrade airport, just on the main parking. So actually you're able to charge EV vehicle only on sunshine at no additional cost. Being said that, we are working in steel industry, and I'm here to give a small overview, or to give the perspective from the market in steel industry, the way we are looking at the reuse possibility. It's out of question that is the way we are all going, and it's one really good thing that we need to do for our planet. Current status is that the experiences in Serbia construction markets are really limited. And Nenad mentioned that there is only one factory that is being done with reused steel, but they had the task to transfer they knew which material they count on, and they were working with that material. For global use, the complication is a little bit more complex, because it's questionable whether in the moment of designing what material is available. I wanted to give our thoughts on this matter through one perspective of widely known SWOT analysis. So let's start with the strengths, what we see that is in this process that are possible, or that are our goals. When we have the ready material, it's a good thing that we don't need to produce it. Yeah. So impact on the global pollution and CO on carbon print is it's really obvious. if there is no obstacles in regulation, we can get faster to raw materials. We don't need to wait for the production, and we are doing good thing, but because we are in that way acting in environmentally responsible manner. So out of question, that is a good thing. What could be challenge there? When we use the material, reuse the material, that the practice says that we don't have the passport of that material. Some buildings are relatively old. It's questionable when if we know whether what is the quality of material. Is it S235, S355? It requires some additional investigation. During the period of the life of that element, might happen that some earthquakes or some other impacts were occurred. So, do we know really the stress status of each construction element? Of course, corrosion is one of the important things, but let's say it's visible, maybe solvable in some as a issue in some visual inspection. For designers, this could be an issue because when they design, they don't have that freedom to go to choose the materials because they have pre-selected list of materials. Available quantities might be also one restraint point, because when you design one, I don't know, frame, you want to repeat that 20 times if you have materials only for 10, then you need additional 10 to redesign for something else. So it generates a little bit more of work. The formation of the element that arrives to the factory could affect the production accuracies. It's a global tendency that the machineries and demands are stronger and higher, and the machinery is quite precise nowadays. So the inaccuracies could affect the technology of and production effect for if the material is let's say bending or deformed in some other way. With the reuse, of course, we have strong opportunities in terms of reduction of raw material expenses. We expect that this material could be cheaper, but of course, this cannot be. This should be communicated with potential sellers. What Nenad mentioned, they shouldn't see the chance that they when they demolish the steel building, that they don't see the chance to, instead of the problem with waste, to see the chance for earning of money. So I guess in that process, the help of government and country is necessary. As a company, we are a step closer toward ecological goals. So the company nowadays, every company needs to have the ecological goals, and of course, we need to build up the reputation as sustainable companies. Important, and as I mentioned, that some help of the government agency needs to be embedded here, because through some opening of the green fundings or green initiatives, and also utilizing reuse steel can reduce dependency on fluctuating raw materials markets. Situation in the world in last let's say 5 years or more was like that we were witnesses of all of a sudden changes in raw materials, so that prediction could be more fixed with the bigger portion of use of reused steel materials. Threats we have is that we could risk the customer dissatisfaction, because This is some management of expectation needs to be implemented here when they related to the final product what they get. We have one risk in supply chain with possible inconsistent availability or delays in demolishing of some buildings that could affect the production of or reuse of the material. Finally, with this, in this way, we are aware that we reduce the raw material cost of the final product. But the global tendency is that the work or manpower is tending to grow, which is in some way compensating the final price of the product. I would close with this, and I would like to thank you for your attention, and I'm open for your questions. Thank you.
Thank you, Nicola. So yes, now we have some 5 minutes left over for questions. So if there is anyone in the audience who would like to ask a question, once again, you can either write it in the Q&A section, or you can raise your hand and we can give you the word. And if there are no questions in the audience, then I would have a question, and I would like to ask Nenad, what do you think are the biggest issues for massive reuse of steel structures in Serbia?
Thank you. Thank you for that question. We already discussed this issue, and thank you for putting this question. Well, when discussing the challenges that hinder the widespread reuse of steel structures in Serbia, we can categorize them into two main groups, as far as I'm concerned. First of all, there is no centralized registry in Serbia at this moment for buildings that are set to be demolished, especially for the steel structures. This includes dismantling also of the structure. And additionally, there are no official marketplace for acquiring structures that have previously completed at least one service life or service cycle. The only way to gather such information today is to reach out directly to construction companies and investors, or to observe by yourself when demolition or dismantling activities are planned and performed. And the second thing, we already hear Nicola says, if the regulation is all right. So Serbia currently lacks a comprehensive legal framework governing the reuse of steel structures for subsequent life cycles, as well as the necessary standards, regulations, and rule books for the design of such structures. We have numerous buildings which have surpassed their design service life as defined by AN 1990, but yet they continue to operate in a condition deemed acceptable. So this situation underscores the necessity for these structures to possess an extended service life while ensuring continued safe utilization. So under all these circumstances, designers have resorted to implementing various methods. For example, in the case of the Baumit factory, located in Aranđelovac, the designers used higher partial safety coefficients in the calculation of the new facility. And the second approach includes employing second-order theory in calculations, taking into account increased values of initial imperfections and the residual stresses. So therefore, in my personal opinion, addressing these two issues is currently vital for advancing the mass reuse of steel structures in Serbia. And in the end, one comment for Nicola: when we are talking about design of reused structures, let's say we have opposite order. First, you have the list of the material which is available, and then you're performing the design, taking care of that resources you have at the moment. Thank you.
Thank you.
Thank you. And we do have a question in the chat. I will read it out, and then it's not directed at anyone specific, so whoever feels most competent can answer. So thank you for the in-depth presentation of the technical aspects. Could you please provide us with some information regarding the fire protection measures planned for the structure? For example, are concrete-filled steel elements being considered, or possibly cement-free alternatives based on clay soil? Apologies if I've mispronounced that. Also, is there a need for such measures, given that this is a small-scale structure?
Yes, okay, maybe I can start answering this question. Thank you for this question. It is important for us since we are designing a house regarding all standards that needs to be met, but the fire aspect is not a focus of this research, but all elements, for example, concrete columns and walls will be designed to have adequate concrete cover to have adequate fire protection, but this will not be a focus. So we are not considering regarding that some alternatives like cement-free or clay soil elements for this purpose. So this is something, this house is designed to meet all standards for, let's say, residential or office buildings. So in that way, we are following standards, but we are not investigating this as a special aspect. Maybe someone can add some new perspective, yeah?
I can add just that I agree with Jelena, and regarding the rubber connection, it has the certificate of the fire resistance of F90, so that it covers. But as you said, in this, as Jelena said, in this project, we'll not check it in detail, but of course, it will be fulfilled all the demands of the standards.
Perfect. Thank you. And as I believe that there are no other questions in the chat at this time, and that we have reached our time for today, I would like to use this opportunity now to thank all of our speakers for their presentations today. All of the attendees, thank you for being with us today, and I hope that you have truly... Yes, Ivan? You are muted.
Okay, so sorry for this interruption, but before you close, I want to say something. I think it is very important, because Mr. Ristic mentioned that one of the obstacles in higher implementation of recycled aggregate concrete is the cost of recycled concrete aggregate. So according to our experience, it is not, let's say, fully true, because we actually supply these aggregate, recycled aggregate from this plant, recycling plant, and it costs actually €2 per ton. So it is actually cheaper than natural aggregate. So really, I would like to take your attention to the document actually that was prepared by Green Building Council and ordered by Chamber of Commerce of Serbia. Actually, unfortunately, it is in Serbian, but I think most of attendees are oriented to this market in Serbia. And that document is actually a roadmap for implementation of recycled aggregate concrete. Here you can read actually what are the current state of the art in Serbia about this aggregate and concrete, and what we actually need to increase the implementation in the real project. We are not regarding the regulations. It is written there that we are not so far away for implementation. I think that sentiment of the market is crucial for the higher implementation. So if for example, if anyone has doubts regarding the quality, I would say that there is no need to use to start using 100% of recycled aggregate in concrete or 50. You can use only 10. It can affect the quality of concrete minorly or in negligible range, but you will reduce the amount of demolished debris, and increase the environmental protection. So it will not affect the quality so much. So that's something that I wanted to point out. Remember that document, it is available. I believe, Vladimir, maybe you can help me. It is available
on our website, yes.
Yeah.
Yes.
Okay, thank you
for
very
mentioning
much.
it. And Jelena, you wanted to add something?
Yes, just to add something to Ivan very shortly. Yes, in Serbia we have, let's say, a good situation now that you can purchase recycled crushed concrete, but in this moment that aggregate is not certificated for the application in concrete. So you need to further either crush it or sieve it and need to test it. So those are also the aspects that will increase the price in some way, but there are a lot of economical systems that can or changes that can be made, mostly by the government, that can make recycled concrete aggregate with a comparable price to, let's say, crushed aggregate. So in future, if there is an incentive from all stakeholders, that this can be true. Thank you.
Yeah.
Thank you.
Thank you, Elena. It's fully true. It's fully true, and we emphasize that in the document actually that the crucial moment is transferring something from the waste to secondary raw material. So that moment must be regulated better, and after that we will have a road ahead of us for higher implementation of RC.
Yep. Thank you for those comments. It was very valuable to mention the study as well. Yes, so thank you for bringing it up. So as I was mentioning, since we are a bit over time, thank you everyone again to the speakers for all of their insights today that they've shared with us, to the attendees for being with us and for showing interest. We continue to please follow along the project on our website, on our social media. We will publish this webinar, the recording, so if you want to come back to it at any point, you can. And the announcements for all future webinars will be posted on the project, so please keep in touch with us. And if there's anything else, please feel free to reach out to the project if you have any additional questions. And that's it. Thank you, everyone.
Thank you.
Thank you.
Bye-bye.
Bye.
Thank you. Bye.
Thank you.